Thank you. Thank you very much. I'm going to talk about the official Go SDK, which some of us on the Go team have been working on pretty intensively for the last month or so. And even though I'm on the same stage as I was on Tuesday, and this is the same room, let's do this a little more informally. You can interrupt with questions. I can't really see everybody, so instead of raising your hand, you have to make a noise, and that noise is yo, and not the way I said it. I'm going to teach you guys the proper New York yo. So let's practice. I say yo, you say yo. That's good enough. All right. Brief introduction to MCP first, and then I'll go over the design and give you some examples of our SDK. What you will not hear about is any real, I just want to set expectations. I won't be doing big end-to-end examples of how you hook this up to agents and stuff. Never do live demos, so I won't do that. Nothing agentic or any English words that are real words that sound like agentic. And there's really no AI in this talk at all. So Model Context Protocol, it's a protocol for large language models providing context to them, which is the stuff they know before they can do whatever you want them to do. It was developed by Anthropic in an attempt to unify disparate APIs that different companies had. And perhaps because of timing, because it was well designed, both of those, it's absolutely taken off. So in the terminology of MCP, there's a client and a server, and the client lives inside a host, which is some box or something, and that host consists of, there's an LLM there accessible to it, perhaps not on the same box, but conceptually adjacent to the client, and there's probably a UI for the user so they can interact with it. So the most important feature of MCP is tools, and as Matt said quite accurately, a tool is essentially a function, and it works kind of like this. The client says, using MCP to the server, what tools do you have? So there's a list tools, part of the API, list tools function. And it says, well, I can tell you the time in a city or the weather. I can also do something with Redis. And as Matt very importantly pointed out, you need natural language descriptions so the LLM can understand it. And you also, MCP has is the idea of the types of these arguments. And those types are expressed in a language-independent way using JSON schema, which I'll talk more about. And the client then says to the LLM, the client reports the server's information to the LLM, so the LLM can use it. And then the user says, what's the weather like in Boston? And now the LLM, knowing the tools available, tells the MCP client, okay, call the function or the tool, what's the weather now in Boston? And the client asks the server to invoke that tool. The server replies in some, that tool replies in some, computery way. And then your client gives it to the LLM, and the LLM, LLMs it up. It does its thing, its natural language thing, and you get some beautiful sycophantic answer from the LLM. Another feature that it has is prompts. Maybe your server is a storehouse of excellent prompts for doing things. And the model here is that those prompts are templates of some kind, not necessarily Go templates, but there's placeholders in there where you can substitute in strings. So the client says to the server, again, there's a list prompts thing. The server says, here are all the prompts. You can prompt me for getting a recipe with ingredients or writing a cover letter with your qualifications or whatever. And then somehow the client gives that list to the user. Maybe it's a drop-down or something, and the user says, okay, I want to do the recipe thing, and the client says to the server, now I want to get that prompt, just give me that text, but fill in the placeholders with these things. And the client passes that prompt on to the LLM, and then the LLM, figures it out, uses the prompt to do whatever was asked. And there's a lot of other features. There's this thing called resources, which is the idea that the server might just make available to the LLM, say, files in a file system, or URLs from the web, or just hard-coded bits of information, or rows from a database. Could be anything. It calls those resources. Could that also be done with a tool? Yeah, but resources, for some reason, they're a little more tailored to that particular case. there's this idea that the server, the tool, the thing running on the server, whether it's a tool or not, can call back into the client to ask the LLM a question as a kind of subroutine, and then that can come back. They call that sampling. And there's a ton of other stuff, some of which I'll talk about later, some of which I won't, because it's a short talk. I also, by the way, do want to leave time at the end for questions. So I'm going to try to do that. There's a lot of servers out there already. 3 or 4 weeks ago, when I first gave this talk internally, there were 13,307 on this particular website, which I found by Googling and taking the first result. It's called mcp.so. And now there's, 2 days ago or so, there's 15,483 servers. Just on this little, site of, aggregation site of servers. And the servers, people can do anything. You can serve up Edge 1 pages for some product named Edge 1 that I've never heard of. I mentioned Redis. You can serve up Redis. You can ask for the time. There's tons of stuff. So this ecosystem is already incredibly large, which is kind of amazing. There's even a server for Go Please, which you can't use yet. Go Please is our language server implementation. But the tool here, there's one tool, and it's basically like, here's, line 43, character 87 of foo.go, and you get back everything about, all the information about that particular location, including the source of that file, everything it depends on, I guess other stuff, maybe type information. I'm not even sure what's in there. I think the implementation per se is complete, but hooking it up to various things like Go Please itself and making it available to other, other tools like Copilot and stuff, we're not there yet, but we're working on that. So yeah, this API has just this framework, this protocol has just blown up. It started sometime in November. Anthropic announces it late November, yada, yada, yada. And then you can see these are the GitHub stars of the Python and the most prominent, the most popular Go SDK, Mark III Labs, MCP Go. You can see they start taking off just around sometime. Somebody on the issue tracker for the repo for this thing, the github.com model context protocol, not us, somebody else said, maybe we should have a official Go SDK. And shortly after that, we committed to doing that, so we opened up a can of Ninja on this thing, and we formed a small task force of people who were going to take time away from whatever they regularly do, usually work on static analysis tools, like that Go Please inline thing. I did a little tiny fraction of work on that. But I got pulled off of that stuff to work on this thing. This was like, oh wow, I thought it was a month ago, but maybe it was 2 months ago. So we've been cranking on that for a while. And took a while to get legal approval because, Anthropic and Google are competitors, but they're also working together on this. So what does that mean? Who gets to sue who? Will the government sue both of us? We don't know. So we have this legal framework now in place. And we are so close. I was really hoping to announce today that this was pushed, but it is not. We are so close that the latest CL is, here's the script that's going to let us push this thing and retain history and everything. That's how close we are. We're so close, and it'll be and it's a US holiday today, so nothing's going to happen today. So it'll be tomorrow or Monday or Tuesday or something. The code is all visible. It's just in an internal package. Yeah, so that's the history. And I'm going to now talk about some of the aspects of the design. No questions. So yeah, I showed you this before. Just to remind you, there's a client and a server. And they talk over, MCP specifies the full stack. So it doesn't actually say the lowest level of the protocol. I guess it assumes it's HTTP. But it defines this notion of transport, which are different protocols on top of HTTP, I guess application layer protocols you'd call them. And this is the way we've interpreted that. There's a client and a server, and a single client can have multiple client sessions. And each client session works with a single client transport, which connects to a single server transport, which connects to a single server session, So client and server, you can think of them, and other SDKs use different terminology, but you can think of sort of them as templates. In particular, the server is something where you'll install all these tools and prompts and resources and stuff, and then it can handle multiple connections to multiple clients. And similarly, a single client can handle multiple, it can talk to many servers. The same client can talk to the Redis server and the recipe server and whatever, which is not exactly what the spec says, but it's sort of in the spirit of what the spec says. And everyone does it differently anyway. And yeah, so this is how you do it. But this is an in-memory transport, which you only use for testing. But you create a new in-memory transport, and you get both ends. And then you say, let's make a server, and connect the server to a server transport, giving us a server session. And I write the error in italics, indicating that I should be handling it, but I'm not. And then you make a client and connect it to the client session. And now connect it to the client side of the transport. And now we're all connected. The client section talks to the client transport, talks to the server transport, talks to the server session, talks to the server. And there's several kinds of transports. Whoops. I wanted to move around, but not that much. There's several kinds of transports. The inter-process one here, this is intra-process for testing, but you can also, a common mode is you run the server on the same machine, and you talk over standard in, standard out. That's, again, part of the spec, and we provide that standard in, out transport. There's an HTTP server session events form. There's a streamable HTTP kind of thing that are kind of complicated interactions using get and post that I won't go into. But we provide all of those. All right, let's talk about tools. The spec says that a tool looks like this. The actual official, there's English in the spec, but there's also the official, formal part of the spec is TypeScript. TypeScript, I guess. So this is TypeScript that says a tool has a name and a description and an input schema and an output schema. And you have a tool request that takes the name and a bunch of arguments. The name's a string, and this notation at the bottom there means a map from string to any. That's what it means in TypeScript speak. And it's confusing because they call these RPCs, they call them methods, because that doesn't mean Go method. It means JSON RPC method, because JSON RPC is the underlying. They actually specify that this is all done with JSON RPC. Yeah, so this is what the Go for that looks like. Tool is a struct with a name and a description. And because it's JSON RPC, we have JSON tags for everything. Now let me talk about the input schema and the output schema, because that was the first thing I got nerd sniped into doing. We wrote a complete JSON schema implementation from the ground up. I didn't like anything I saw out there, so I wrote my own. Yay, except modified yay, because it's not public. It's going to internal now. Everything's internal, but even when we publish it, that'll be internal, because not that it's bad or stuff, but we don't know how to support it, meaning we don't have resources to support it. Like writing something in an intense period of 10 days was really fun, but then maintaining it for the rest of my life, maybe not so much fun. So, no, but we have a sort of a plan for that. We're going to distribute the load among other people at Google, and I think we will get it out there soon, but not just yet. But yeah, it does all the things that I wish all the other ones did. It validates. It gives you the schema as a struct with exported fields, so you can create a schema with a struct literal. You can do inference, so you give it a Go struct, and it constructs the JSON schema for you. And we will use that in a second in this API. Yeah, because one of the things the spec says is that tools must use their input schema to validate their inputs, which is a good thing because you don't know what crap the LLM is going to give your tool. So it's nice to have that guarantee. So we do provide that out of the box. Yeah, call to params is, so what we did here is kind of a weird split where on the client side, call tool param, you can pass anything as an argument, and it will anything that's JSON serializable, but the server tools will specify a particular type, and you'll get it in, the server tool will see it as a particular type. I'll show you an example. Yeah, so a tool handler, a server tool is the tool description I just showed you plus its associated handler. And that handler takes a typed set of arguments, basically. That's what you're seeing there. Yeah, so here's an example. The say hi function is a tool. And its arguments are this hi params thing. That's confusing that it shouldn't be called params. But anyway, it just takes a name. That's a string. That's not an interesting case. But it could be any JSON serializable thing, including slices and maps of stuff, as long as it's JSON serializable all the way down. And then the only thing this does, all this is boilerplate. The only thing it does is concatenate that name to the string hi. But of course, a normal tool will do much more. And you see that we use the generics there because it says call tool params for square brackets hi params. So that's why it's able to refer to these in the boldface thing, it's params.name. We didn't have to do an index of a map. We just can use the struct field. And that's nice, a little nice here because we can't spell it wrong, but it's much, much nicer if you have some complicated data structure. And now it's not just a map of an any, which is a map of an any, which is what you'd get with kind of default by JSON, but it's exactly the types that you want. So that's a nice feature that we're providing. And you get all that just by calling new tool. And that's going to infer the JSON schema for you. So in order to add that particular tool that does the say hi function, you just add tools of MCP new tool, name, description, the function. Everything else happens automatically for you. Yep. Prompts are a little, I think, so this is actually work in progress. We had the same thing for prompts, but I think it makes a lot less sense for prompts because prompt arguments are always mapped from string to string. So I think we should just abandon the whole, and there's no schema. So we'll probably just resort to, yeah, there's a map from string to string, and you just index the map. So that's what's going on here. Details are not so important, but I think the important point is it's relatively easy. This code looks messy because there's a lot of line breaks that you wouldn't normally see because I made the font as big as I could to show up for you guys. But it's really not a lot of code. And we're thinking of maybe we should provide something that if you have a Go text/template, we should just let you provide that and it would figure everything else out. But we haven't done that yet. I mentioned that there's these list APIs. You can list the tools. You can list any of these so-called features. The client can ask the server, what have you got? So we provide that with the way the spec says. The first thing, list tools, for example. And they do that the absolute right way for an RPC, which is you get a bunch of stuff back with a token that lets you get the next page. So it's page-oriented for efficiency, and you have to ask for the next page because there's no streaming in HTTP, not at the level they wanted to provide. But we also provided iterator versions of everything, where you get one thing at a time and you totally don't see the pagination or any of that stuff. Yay. I assume you're doing that because it's an applause and not just because you're tapping. OK, fine. Logging, so part of the spec says the server can just produce log messages that the client can consume. I think that's a very smart idea because people want to know what's happening when their server is taking a long time. That's nice. And we did that with slog. So you just get a method called new logging handler. You can wrap that with slog new. You get a structured logger. And then your server can just use slog to write to that. And it goes back to the client. Middleware, we're happy with this design, even though it's going to sound complicated when I describe it in my very fast New York talking. So there's a method handler, which is basically something that handles a method. And here method, again, I mean the JSON RPC method, or the RPC. It takes the name of the method and params in some abstract way and returns a result. So a very general signature for handling something. And then a middleware thingy I hate saying a middleware, but middleware is some sort of function from method handlers to method handlers. And again, this may be confusing to you, but it's exactly the concept of middleware that you're used to from HTTP servers. And so you can use this there's two ways to use this. You can use it on the sending side. In this protocol, the client is not always the sender. The server can also send things to the client. Because remember I mentioned that so-called sampling part of the API where the server can ask the client to ask the LLM something for it. So there, the server is the sender. So both of those can register middleware when they send something and when they receive something. So on the sending side, one use case for that is there's concept of progress. I want to get progress information about my long-running activity in either direction. The sender, so that's the sender asking for progress, and you do that by setting this thing called a progress token. And this is, so add progress token here fits that middleware type. It basically says just increment a number and set it into the params. So every outgoing request will get a progress token. And then you just insert that into either your client or your server with add sending middleware. And on the other side, oh, I didn't show you the other side, but because I woke up too late this morning, but back. So the other side kind of looks the same, except it would be add receiving middleware. What's the use case for that? You want to just log, now you want to log locally on the server. That this is exactly like the case of an HTTP server middleware. So receiving middleware is like your HTTP server middleware. You log on the server, this request is starting, this request finished. Classic server-side logging of incoming requests. And anything else you'd want to do on the server side, you'd use receiving middleware for that. Metrics, so on. Yeah, there's other things I could talk about if you ask me, like resources, routes, the auth story. And we're going to keep working on the implementation, but it's usable now. That is, by now I mean a day or two from now when we actually push it. It's very important to, why can't we just be a bunch of engineers and all get along? Well, because Google and Anthropic are competitors, even though we're collaborators on this. So we need a little more structure to deal with issues that we have to escalate, with issues that fall outside the realm of technical things like social issues and legal issues and so on. So we're going to establish a steering committee consisting of people from Google and Anthropic and perhaps the community as well. As I mentioned, we're going to push it. That's the QR code. Refresh that obsessively for the next week until you see something. And we will, at that point, once it's out there, we will begin accepting contributions. I know a lot of people are very eager to contribute to this, and we want to get the community involved. We just wanted to get this down first. We wanted to get our design. So you didn't ask me this question, but I'll answer it for you. Why did we do this when there were 3 of them out there already? Well, we looked at them, and we just felt that they had evolved organically and very quickly, because I showed you that exponential graph. And we just thought we could take a breath. And again, as I said on Tuesday, and as I often say, sometimes there's a great advantage not to be first to market, because you can see what's going on, and you can take a breath and do a cleaner job. And we just felt it's the more idiomatic job. And I'll give you one example. Not to knock on Mark III Labs MCP Go, which is excellent, and it's very widely used. So obviously, it's getting a lot of things right. But I showed you the middleware layer, which consists of those 2 types and, I guess, 4 Go methods, add receiving and add sending on the client and the server. That's 6 things, 6 symbols. The way they did that in Mark III Labs MCP Go is they have hooks for every operation. And then there's 3 types with each hook. There's like the hook function, the thing that adds the hook, and something else. So that's something like 21 separate symbols, all individual, and we just were able to do it much more compactly because we just thought about it a little bit more. Not that they didn't think about it. We thought about it more. And that's, I think that's all I have to say, except if you like the little cute gophers that you've seen in this talk and the one I did on Tuesday, they are canonical official Renee French gophers, and they are from an amazing talk she gave a few years ago that I highly recommend everyone watch. It's just absolutely delightful. It's not a technical talk. It's about the designer of the Go Gopher talking very entertainingly about the Gopher. Thank you very much. We have 2 minutes for questions. Thank you. Thanks.